Hi Geometry, this is part of our review for Algebra 2, and it's mixed factor review, so we have different types of factoring on the same page. Let's review a little bit of what we've been learning. When we have three terms, this might be factorable by using our diamond method. When we have four terms, this might be factorable when we underline the first two and underline the last two, and we try our factor by grouping. And when we have two terms, like always, we should check for a GCF. It could be a GCF problem. It also could be the difference of two squares. And remember, in any of these cases, if my polynomial is not factorable, it could just be prime. I do believe on this assignment, none of these polynomials are prime. So you should be able to factor each and every one in some way. So let's take a look at number one. There's only two terms here. So I'm first going to look for my GCF. 9 and 4 does not have one. So now I'm going to see if it's dots. So let's see if 9x squared is a perfect square. If I take the square root of 9, I get 3. If I take the square root of x squared, I get x. Let's do 4. The square root of 4 is 2. So this is the difference. Notice that this is a minus sign. That's super important. It is the difference of two squares. That means it factors into the sum and difference of the square roots. So 3x minus 2 and 3x plus 2. If I wanted to double check my answer, I would box or FOIL this and see that I get the same polynomial back. So I'm going to check this one just to make sure I did it right. So I'm going to create a box so that I can multiply 3x minus 2, and I can put that down the side or across the top, times 3x plus 2. Again, down the side or across the top doesn't matter. 3x times 3x is my 9x squared. Negative 2 times 3x is my negative 6x. Positive 2 times 3x is my positive 6x. And negative 2 times positive 2 is negative 4. On my diagonal, I have my like terms, but my like terms happen to cancel each other. So I just get 9x squared minus 4. That matches what my problem was to begin with. I know that I've done my problem correct, and this is my correct answer for a fully factored form. So number 2 appears to be dots when I first look at it, my difference of two squares, but you'll notice that I have a plus sign. Because of that, there is nothing I can do. Oh, I think I said none of these were prime in the very beginning. There is one prime on the whole page, and we just found it. I'm so sorry, geometry. There is one prime, and it's right here. This would be the sum of two squares, and I have no way to factor that. We discussed that in the classroom. If you were absent that day and you want to talk more about it, come to office hours. So let's skip number 3 and go to number 4. So number 4 just has two terms, so I'm going to look for a GCF. I noticed the 3 and the 81. I could grab my calculator. I could divide 81 by 3. I could find that it's 27. So it looks like I have a GCF of 3. So 3 is my GCF. I'm going to divide it out of both terms, and I'm going to get an x squared plus 27. There's nothing else to do with the x squared plus 27. It's not the difference of two squares. It's finished. This would be my answer. So let's take a look at number 5. Number 5 is a trinomial, so you might be thinking diamond method. But I'm not ready for diamond method yet, because first of all, this has an x cubed. Well, that's kind of interesting. I know that I have to have an x squared term to use my diamond method. So I look at each of these. I happen to start noticing, oh, they all have a factor of 7. Oh, they all have an x. This is a problem where I need to get my GCF factored first. Looking at 7, 14, 7, my GCF is 7. Looking at the x cubed, the x squared, and the x to the first, I'm going to have an x term in my GCF. And remember, it's the lowest exponent. So in this case, it's my x to the first. You don't need to write the 1 there. And now I'm going to divide each one of these by 7x. So 7x cubed, the 7's cancel, and x cubed divided by x to the first, I subtract my exponents, I get x squared. 14 divided by 7 is 2, x squared divided by x is x. 7x divided by 7 is 1, x divided by x is 1, so I have a 1 left here, not a 0. 7x fully cancels 7x when I divide by it, and I have 1 left over. So now I'm going to use my diamond method. This time there's now a 1. I'm going to ignore the 7x in front. There's like a 1 in front of my x squared. So a times c is 1. That's what I have to multiply to. My b is 2. That's the number I have to add to. So when I'm thinking of my side numbers that multiply to 1 and add to 2, I get positive 1 and positive 1. So I'm going to put those in my parentheses since my a is 1. So I have 7x times x plus 1 times x plus 1. This is the perfect way to write your answer. I will say x plus 1 times x plus 1, this is the same thing. You could think of this also as 7x times x plus 1 squared, but that's not necessary. But just if you were wondering about that, that'd be correct. So number 6 is another problem where there's only 2 terms. Why don't you check for a GCF first? Now number 7 has 3 terms. When I look for a GCF, I see 2, a -1, a -3. My terms don't all have an x. There's no GCF. It does have 3 terms. I'm going to see if it's factorable by using my diamond method. So I do my a times c. Remember, this is ax squared plus bx plus c. So my a is 1. I'm sorry, my a is 2. And 2 times -3 is -6 on top. That's my a times c. My b is -1. That's the number in front of my x. And so now I'm trying to think of 2 numbers that multiply to -6 while adding to -1. So hopefully you're thinking about using 3 and 2, and you can write them on either side. I need the 3 to be negative and the 2 to be positive. So when I multiply them, I get my -6, and when I add them, I get my -1. Now, my a is 2. Be really, really careful. When I have 3 terms, I'm going back to the top of my page, and my a is 1, my side numbers can go directly in my parentheses. When my a is not 1, my side numbers then have to go back into my polynomial, and I'm going to use my factor by grouping skills. So I'm going to keep my 2x squared. I'm going to keep my -3 at the end, but I'm going to change my -1x to be -3x plus 2x. Those 2 terms you could put in either order. I could do positive 2x minus 3x, or I could write them how I did. But remember, both those are equal to my -1x. I haven't changed my problem. I've just changed it into 4 terms. So, however you have it set up, I'm going to underline the first 2 and the last 2. In the first 2, I have a GCF of x, and I get 2x minus 3 when I divide it out. 2x minus 3 has nothing in common, so I have to factor out a positive 1 so that I have something that I can throw in my leftover parenthesis. My same parenthesis is my 2x minus 3, so let's factor that out and throw the leftovers in my leftover parenthesis. That would be an x plus 1. Oh, that looks like an 11. Sorry about that. Let me see if I can go back. There we go. That's my x plus 1. Number 8 is 3 terms. Why don't you try using your diamond method? You'll notice your a is 1, so you're just going to be able to throw your side numbers in parentheses. 9 is exactly like 8, so you can give that a try. So let's take a look at 10. So 10 is a trinomial. I'm going to see if it's diamond method. I do need to scan it for a greatest common factor, but there isn't one. 4, 20, and 25 don't have anything in common for all 3. The 4 and 20 have a 4 in common, the 20 and 25 have a 5 in common, but they don't work for all 3, and all 3 terms don't have an x. So this is going to be my trinomial factoring where my a is not 1. So I'm going to do my diamond into factor by grouping. So at the top of my diamond is 100. At the bottom of my diamond, well, that's my A times C, 4 times 5. At the bottom of my diamond is my B, which is negative 20. And I believe we had this diamond in our Google Slides. But to get to 100 to multiply, I'm thinking 10 times 10. And to get to negative 20, I'm thinking they have to both be negative. So let's try that out. Negative 10 times negative 10 is positive 100. And negative 10 times plus negative 10 is negative 20. Awesome. So don't write those in your side numbers. Instead, let's change this to a 4-term polynomial. So I'm going to stick my minus 10x in. And remember, order doesn't matter, but since it's the same number, I mean, it really doesn't matter. So now let's underline the first two and underline the last two. So this has something going on with my GCF. The 4 and the 10 are both even. So I'm going to take out a 2, and there's an x in both terms, so I'm going to take out an x. And my smallest exponent is x to the first, so it's going to be an x to the first. 4x squared divided by 2, that's going to give me the 2. And the x squared divided by the x is going to give me x to the first. Negative 10 divided by 2. So, I'm sorry, I got interrupted by our bell. Negative 10 divided by 2 is the negative 5, and x divided by x would cancel. So I'd get a 2x minus 5 in my parentheses. Now let's do the last two. I noticed that I have a negative 10, so I know I'm going to be factoring out a negative something here. So 10 and 25 have a 5 in common, and they don't both have an x, so it's just going to be a negative 5. Negative 10 divided by negative 5 is a positive 2, and I'm going to just have the x because I didn't cancel it. And positive 25 divided by negative 5 is a negative 5. My parentheses match, which they should, so I feel good about that. So let's factor out my 2x minus 5. And in my leftover parenthesis, I get 2x minus 5. So this is how I would write my answer. I do notice that they're exactly the same thing. You could write this as 2x minus 5 squared, but it's not necessary. I just wanted to point that out. So 11 and 12 are the same type of problem as 10 and 7. You're going to use diamond method into factor by grouping. Let's jump down. When you get to when you get to 13 and 14, there's only 2 terms. Why don't you go back thinking about dots, see if dots works. On number 13, you should do a GCF first. I know dots works instantly, but there is a GCF that you need to take out. Whether you take it out first or you take it out in your work is up to you, but just think about that. Number 5 is a trinomial. Why don't you try your diamond method? Notice your A is 1, so that's the shortcut one where you can just put your side numbers into your answer. Number 16 is 2 terms. Why don't you try your dots? Number 17 and 18 are both 4 terms. Why don't you guys try your factor by grouping for those 2? And then if you were absent, number 19 and 20 in class I omitted. There's nothing wrong with them, but they are an x to the 4th, not an x squared. And so we were doing this in class to talk about Algebra 2 next year. But we didn't specifically do any of these problems in our lesson this year. They factor exactly the same, except when you look at our answer key solution, you'll notice that there's an x squared inside my parentheses and not an x. It's slightly different. So if you weren't in class, don't worry about those two, or come by office hours if you want to talk more about them. Good luck, you guys.